Finding maximum and minimum element in an array using divide and conquer strategy. So divide and conquer strategy is when we have a problem, we first try and divide it into sub-problems. Then we try to find the sub-solutions of those sub-problems. When we are done with finding the sub-solutions, we try to merge the sub-solutions into solution. So it is basically divide, conquer, and merge the solution. So whenever we are given with a problem, we can solve it in n number of ways. We have so many strategies to solve the problem. So this is one such strategy, which is called divide and conquer strategy. So in order to find minimum and maximum element in an array, we have so many approaches. One such approach is sort the complete array into ascending order and then identify the first element as the minimum element and the last element as the maximum element. Another approach can be choose the first item or any item as the minimum element or the maximum element and then iteratively keep comparing the next item to this assigned minimum or maximum element. When you find a minimum element, update the minimum label to this new min. Similarly, whenever you find a new max, update this actual max label with the new max value. So this is an iterative process. Now what we are going to see is another approach which is called the divide and conquer approach. So let us take an example. So here we have an array of 8 elements. Now without actually comparing each and every element with each other, I'm going to use divide and conquer strategy such that I divide the given array appropriately and find which is the min and max value. So now that first step, I divide the complete array into two parts. So when I divide the given array into two parts, I get two arrays, two sub-arrays, each n by 2. Okay, so 8 by 2 is 4 plus 4. Now I have again more elements, so I can bring it down. So I'm going to divide it further. So dividing it further at the midpoints. So again I get n by 2. Right. Now I have two elements each. In each array I have two elements. Now I have some place for comparison. If I have more than two elements, then it is not possible for me to compare easily, right? So whenever I have 0 element, 1 element or 2 element, then I go for comparison. So here I only have two elements. So my maximum value is 54. Minimum value is 49. Similarly, here in this sub-problem, the maximum value is 76 and minimum value is 22. Similarly, here the maximum value is 43 and minimum value is 37. Again, here the max value is 68 and min value is 12. Now I have to combine the solution. So I combine the solution of this and this subarray. So my maximum value is comparing 54 and 76. Max value is 76. And min value comparing 49 and 22. The minimum value is 22. Again here I am going to compare the solutions. So maximum value is 43 and 68. So maximum value is 68. Comparing 37 and 12, the minimum value is 12. Further combining the sub-problems, maximum value is 76 and minimum value is 12. So comparing 76 and 68, maximum value is 76. Comparing 22 and 12, 12 is the minimum value. So when we solve this given array, okay, we want to find the maximum and minimum element in this in the given array. So using divide and conquer, this is how we'll be able to identify the maximum and minimum values. The algorithm to find the minimum and maximum element in an array using divide and conquer is presented here. So we are giving four inputs. First is the lowest index, then the highest index, maximum value, minimum value. So these are the four values. So first we are going to check if low is equal to high. So if low is equal to high, it means that we only have one element. So say if low and high, both the labels are pointing to the same index, which means that there is only one value. Say for example 3 here. So what I will do, I'm going to assign that one value as the minimum and the maximum value. So this is the case when we have only one element. Now the next one is next option, which is low is equal to high minus 1. So this is the case when we have two elements. So say I have in the first index I'm having a value 3 and in the second index I'm having a value 4. So when my low is equal to high minus 1, which means I only have two elements here. So in that case, what should I do? I should make a comparison, right? So what is the comparison? A of low, which is the first item, if it is greater than the second item. I'm checking if this item is greater than the second item or not. So if it is greater, then what I will do? I will have to allocate this item as the max and the other item as the min. Otherwise, what I will do? Max value is high and min value is low. So this is the comparison. If it is going to change, then how I'm going to swap it. Otherwise, it remains the same. Next, if we have more than two elements, so then what happens? I'll have to divide the complete array into two parts. So I will first find the mid. Mid is equal to low plus high by 2. Then I will recursively apply min-max algorithm. So for that, now we have two arrays, right? So first I will apply it for the first array, then I will apply it for the second array. So between low and mid, I will identify which is the max and min. Again, I repeat the same process for the second half, which is mid plus 1 to high. And then identify what is the max and the minimum element. Then I have to make a comparison between which is the max from the first half or the second half, which is the maximum. Similarly, from the first half and the second half, which is the minimum value. So that comparison I'll have to make and finally come to a realization of which is the minimum and which is the maximum value. Time complexity analysis. So usually when we have a problem which is being solved using the um, divide and conquer strategy, we represent the time complexity using a recurrence equation. So here, if we have only one element, there is no need for any comparison. If we had two elements, then we will at least have to make one comparison. Now, if there are more than two elements, then we have to divide the array, right? So this can be written as 2t of n by 2, right? This is t of n by 2 plus t of n by 2 plus 2. So it is of the order of O of n. Even though when we compare it to the name method, in the divide and conquer strategy, the number of comparisons are less. So we, however, we are going to represent both of them in the order of n.